two functions. Chapter 3. Polynomial and rational functions. All chapter 2 homework should be done between now and Monday. So in my math lab, chapter 2 homework, please, by Monday. Okay? So polynomial and rational functions, the first situation that we're going to look at is quadratic functions. Then we're going to look at polynomial functions. And you can say, but what is quadratic? Isn't a polynomial? True. What is linear? Is it a polynomial? Yes, it is. But we are going to look here at the higher degree. Degree 3, 4, 5, 6, and so on and so forth. Way more sophisticated functions. Number 3, we are going to look at rational functions. Even more sophisticated than the polynomial functions. And the last item is inequalities that are polynomial and rational. We have not seen those before. Inequalities. Polynomial, and rational. We don't know those just yet. Good. We know everything about quadratic functions. Why do we need to go back? We will go back for two reasons. Number one, I would like us to go through a specific set of steps to graph a quadratic function, although we know everything about it. And more importantly, word problems that change into quadratic functions. Okay? So let's look at, this is 3.1, quadratic functions. And if you say again, I will have to agree. Yes. Not for long. We're not going to take a lot of time. I just want to show you a couple of graphs and discuss the graph a little bit again and look at word problems. Okay. So remember, quadratic functions can be given to us either like this or like this. No, H and K have nothing to do with the circle. It's a convention that we use. We use the same letters, but it has nothing to do. This H and this K do not have anything to do with the circle. Okay, so let's suppose, first of all, we are given this form. Here's an example. F of x equals x squared minus 6x plus 8. Is this in this format? Yes. It does not have the square completed. This is a square is completed here, but not here. This is just a regular standard form of a quadratic function. We're asked to graph it. And we will have to go through the following steps. Ready? In order to graph a quadratic function, our first step will be the shape. What does that mean? We already know from transformations it looks like this. Or it looks like this. Yes, that's the deal. So if it opens up, the leading coefficient must be positive. Awesome. If it opens downward, the leading coefficient must be negative. So these are the two possibilities. If the leading coefficient is positive, the quadratic function looks like this. By the way, the name is a parabola. Only for quadratic functions. And if the leading coefficient is negative, the parabola looks like this. In our case, what is it? Since the leading coefficient is positive, the parabola will have a minimum or a maximum. It will be a minimum, right? So this is a minimum, and this is a maximum. If the leading coefficient is positive, the parabola will have a minimum. So this is our case. In our case, the parabola will look like this. This point is not only the minimum, but it's also called vertex. Only for quadratic functions. No other function has a vertex. Just the quadratic function. Also, we already know because we graphed this function so many times in transformations, it has its own axis of symmetry. I'm not talking about odd or even. I'm talking about the fact that this graph is symmetric with respect to the vertical line that passes through the vertex. So keep that in mind. In step number 2, we will have to determine the coordinates of the vertex. So after we identify whether the function opens upward or downward, meaning it has a minimum or it has a maximum, now we have to find that point. I digress for a moment because I would like you to remember these two things together. What is the quadratic formula? X equals negative b plus or minus square root of b squared minus 4ac over 2a. Awesome. The vertex has two coordinates, right? It's a point. The x coordinate of the vertex, I'm hoping that if you connect it to the quadratic formula, you will always remember. It's this. Just this piece. So it's negative b over 2a. I like connecting things because maybe you can remember them together. So negative b over 2a is the x coordinate of the vertex. Let's find it. We have a, which is 1. We have b, which is awesome. And we have c, which is great job. So let's find negative b over 2a. Negative outside, b over 2a, negative. So you already told me that b is negative 6, and 2 times a will be 2. So then you can identify or determine the x coordinate of the vertex, which is 3. So then the vertex has coordinate 3. And now, how do I find the y coordinate? If I have a function and I say to you x is 5, find y, what will you do? I have a function and I'm telling you x is 5. Please, of course, exactly. Excellent. That's all I needed you to say. It's f of negative b over 2a. So this must be f of 3. No question, right? Is that clear, everyone? Very good. So then I have 3 squared minus 6 times 3 and plus 8. 9 minus 18 plus 8 is negative 1. So after all this work, we finally have one point for this function, which is the vertex, in this case, which is the minimum. The next step is the X-Intercepts. But this is extremely important, comma, if they exist. What does that mean?
If it's above 0.
Excellent. Yes, excellent. But what?
All real numbers.
But what? What is above or below? Excellent. But what? The y coordinate of the vertex or the vertex. Exactly. So let's analyze these three situations. So there are three possibilities for a minimum. This is one. This is the other. And this is the last one. Here, the y coordinate of the vertex is positive 0 or negative, which is not the case. Here, the y coordinate of the vertex is positive 0 or negative 0, which is not the case. So we are looking at the third and the last option. Do the X-intercept exist? Of course, they must exist. Because the y-coordinate of the vertex is a negative number. So because if you say it's the first one, I'm not going to waste my time and try to find them because they're imaginary. I will not be able to find anything. So that's why it's very important to analyze the situation by looking at the vertex. Since the y-coordinate of the vertex is a negative number, obviously it's this situation, not this and not this. Good. We still have the same three options. In the case of the maximum, we still have the same three possibilities. This, this, and this. So if the maximum is a positive number, then it will cross the x-axis twice. If the maximum is 0, this is exactly the x-intercept and the vertex. And if the maximum is a negative number, it will not touch the x-axis. I just took my tent away. Okay, so then let's find the x-intercepts. So how do I find the x-intercepts for any function? I said what? I know you know. Okay, we said y equal to 0. Very good. X squared, what was it? Minus 6x plus 8 equals 0. We have 4 methods of solving this equation. You want to try completing the square? No, of course not. Because it's very easy to factor, and I will never complete the square unless you force me to. So, what is it? Very good. So there are 2 options, x equals and x equals. Good. So what are the ordered pairs that we just determined in this case? 2, 0, 4, 0. And number 4, the y-intercept that will always exist. How do I find it? Very good. Awesome. So I find f of 0. Can anyone give us f of 0? 0, 0.
8.
Very good. So the ordered pair is?
0, 8.
Excellent. 5, 6, and 7 are just words, but important words. So the axis of symmetry is, remember, we are not talking about odd or even functions. We are talking about that axis, the vertical line that passes through the vertex. So the point is 3, negative 1. Which vertical line passes through 3, negative 1? X equals 3, of course. Perfect. We decided that this function has a minimum or a maximum. Minimum. Okay, the min value is, how low does it go? Negative 1, but that's where the minimum is. But the minimum, remember when we talked about max min, we said where it's located and how much it is. So it's negative 1. And now the range. And you can say, but we haven't even graphed it. Yeah, but we know the graph. We already have it on our minds. What is the range of this function before we even graph it? Negative 1 to infinity, of course. See how much you learned in this class. Okay, we're ready to graph it. Now, we basically dissected this function to the minute pieces of it. Any questions, please? Go ahead. I think someone had a question for me. Yes? Yes? No? Okay. So let's graph. We always start with the vertex, which is negative 3, 1. Which is 3, 1. 3, negative 1. I'll get it correctly eventually. We have to draw the axis of symmetry, which is a dotted line. It's not part of the graph, but it has to be graphed. Then we have the x-intercepts 2, 0, 4, 0. Notice that they have to be symmetric left and right of the axis of symmetry. In this case, 1 unit away. We also have 0, 8 as the 1, 2, 3, 4, 5, 6, 7, 8 as the y-intercept. We are ready to graph. Please do not graph it too acute at the vertex, and try to make it as symmetric as possible. Mine is not very good. So this is f of x equals x squared minus 6x plus 8. I would like to, I know we only have about 7 minutes. I'd like to look at a word problem here. And then we'll come back and we'll graph the other shape as well. Okay. So here is a function. Let's say we want to look at problem 60. A ball is thrown upward and outward from a height of 6 feet, and the height of the ball, f of x in feet, can be modeled by this. What type of function is this?
Quadratic.
Quadratic. Does it have a max or a min?
Max.
Max, because the leading coefficient is negative. So when I throw a ball, what will happen is it reaches a maximum and eventually will hit the ground. Okay, good. So it has a maximum. It's a quadratic trajectory with a maximum and a negative leading coefficient, in other words. Very good. We're asked here, where x is the ball's horizontal distance in feet from where it was thrown. What is the maximum height of the ball, and how far from where it was thrown does this occur? How far does the ball travel horizontally before hitting the ground? And graph the function. Ready? So let's copy the function first. So this is our problem 60 on page 361. We are given f of x as negative 0.8x squared plus 3.2x and plus 6. Part A, one more time. What is the maximum height of the ball and how far it reached the maximum from the point it was thrown? Okay, so how do I address that question? What do I need to find? The vertex. That's all I need. Find the vertex. Perfect. So what did we say about the x-coordinate of the vertex? Excellent. Thank you. Negative. B. Be very careful. The polynomial, in other words, the quadratic function, has to be arranged in descending order. If it's not given to you in descending order, first you have to rearrange it, because otherwise you will potentially identify the coefficients incorrectly. Good. So then negative b. What is b? Very good. How much is 2 times a? It's negative 1.6. 2 negatives. Of course, there cannot be a negative number as a result. So this is 2. The measurement unit, they are all given in feet. So this is 2. So the question now is, how much is the height? How high does it go? How do I find the y-coordinate of the vertex? Very good. So f of 2 equals negative 0.8 times 4 plus 3.2 times 2 and plus 6. So negative 3.2 plus 6.4 and plus 6. So this will be 3.2 plus 6, 9.2 feet. Part B. How far does the ball travel horizontally before hitting the ground? Can anyone give us the y-intercept of this function? Very good. Y-intercept is 0, 6. So because I want to start the graph. So 1, 2, 3, 4, 5, 6. The vertex is 1, 2, 6, 7, 8, 9.2. So I already know something like this. So I have the vertex and I have the y-intercept, which is 0, 6. The vertex is 2, 9.2. Okay, so our next question is, how far from where I stand my whiteout landed? What does that mean? What am I asked to find? I'm asked to find the x, indeed, the x-intercepts. How do I find the x-intercepts again? Very good. Y equals 0, so negative 0.8 x squared plus 3.2 x plus 6 equals 0. I have 2 more minutes. Hopefully we can finish it. So I will multiply definitely by negative 1. So 0.8 x squared minus 3.2 x minus 6 equals 0. So I'm going to put this in the quadratic formula. 3.2 plus or minus the square root of 3.2 squared minus 4ac over 2a, which is 1.6. So I'm calculating now, so I don't hold you over. I see you already packed. So 3.2 squared plus 4 times 0.8 times 6, and divide by 1.6. So the first solution is 5.39 feet. But of course, the other one will be behind us, will be negative. So I determine that as being negative 1.39 feet, which is going to be here. But this one is 5.3. So this was 2, 3, 4, 5.3. So here's the graph of the trajectory of the ball. And we graphed, that was part C.